Hi students, welcome. It is Tuesday, nope, it's Wednesday, the 3rd of March. We're digging into our situations to equations, Desmos day 2. Several issues here that I wanted to address and walk through. So there's going to be a couple of videos on this. Watch them, walk through the Desmos together as you're walking through this. Pause it when we say pause so that you can grow your understanding. We're going to finalize some of this stuff tomorrow. And so, yeah, let's take a look. We're on the do first here, and we can see that we have 3 different figures, right? Figure 0, 1, and 2. So we're going to try to say, how many dots will the next 2 patterns have? So if n equals 3, how many dots will we have? And n equals 4, how many dots will we have? Well, we can see there's 1, 3, 9. And so the goal for you to see is that it is growing by multiplying the previous figure by 3. So 9 times 3 is going to give us how many? 27. And then our next one, 27 times 3, is going to give us 81. You don't want to draw that out, right? You don't want to have to draw out 81 dots. And so this is why you have to have this conceptual understanding of these patterns so you can identify them without having to draw them. All right, but now the question really is, how else would you describe and explain this dot pattern? All right, so go ahead, take a moment, either use the text box and or the math box here and describe it. Come back and then I'm going to tell you how I would describe it. So pause. All right, hopefully now you took a shot at looking at this, and there's several ways to describe this. You could describe it as a geometric sequence. You could say it's an exponential function. You say its growth, right? Its growth rate is 3. That means multiplication by 3, right? You could also say its initial value is 1, right? Figure 0 had 1 dot. And so those are all really good ways of describing this. Okay, now the best kind of finalized way of talking about this is to write the function, right? F of x equals its initial value of 1 times its growth rate of 3 all to the x power. So we plug in figure 1, we get back 3, figure 2, we get back 9, plug in 3 for x, you get back 27, plug in 4 for x, you get back 81. And so that is that complete way of describing this pattern. All right, so get that down in your notes and then come join me. So we really have 2 goals today. All right, our goal is to determine the difference between decay and growth, and we're going to try to write exponential equations from situations involving percentages. So if you had a bank account and it says it's growing by 3%, what does that mean? How do I show that in an exponential function? If we say the snow is melting at a rate of half per day, right? How do we show that or 50% per day? How do we show that in an exponential function? So we'll walk through here. Here's our agenda. And let's look at these notes, right? Linear exponential situation. We dug into this yesterday. We have it's either linear or it's exponential. Today we're going to focus on exponential. And before we do this, let's flash back to middle school here, where we talk about percents to decimals. And it's really important that you can identify the percent to decimal so that we can move forward in our exponentials. So take a peek here and look at this, all right? All right, so 28% means 28 per centi, right? 100 means centi, or means per 100. That's per cent. And so we divide that number by 100 to get our decimal, 0.28. You maybe just learned, you just moved the decimal 2 places, but I want you to know why, right? Why is because it's a part of 100. So if you look down here, what is 24% as a decimal? Well, 24 divided by 100 is 0.24. All right, so that decimal is 0.24. 100 divided by 100, guess what that is? 1, right? And so that moving 2 decimals, it's going to be 1 as a number. 70, again, you can do this. 70 divided by 100, see that is 0.7. 5 divided by 100, and so forth. So finish these up, and you can do that in your own time. If I have a negative number, it doesn't change, it's just a negative percentage. And we're going to call this decay. All right, as you see, we're moving forward. 2.5, well, negative 2.5, right? So go ahead and plug this in. Now, you're not going to get the correct check mark unless you just put these in all by themselves. See how I get the correct check mark? Because my programming, well, not my programming, the programming here doesn't recognize that. So go ahead and you can go back through there and plug that in. Negative 0.34. Negative 2.5 is going to be negative 0.025. Negative 4 is negative 0.04. And negative 20 is negative 0.2. All right. So you finish those. You have questions about these. I want you to look this up, okay? If you don't understand what just happened here, look up how do I change from percent to decimal, and show that as you move forward. Very important that you have that down. All right. So a 15-second riddle here. I just got promoted and I got a 4% salary increase. What percent of my initial salary do I have now? So let's say your initial salary is what? It's 100%. You make that money. If I increase by 4%, what is my percentage of my initial salary? Well, it's the 100% plus the 4%, which gives us a total of 104%. So if you were making $10,000, right, now you're going to make $10,000 times 104%, right? 104% is 1.04 of your value. So take 110 and multiply it by 1.04. And let me just pull up this calculator here. So I have $10,000 times my new increase is 1 plus that 4%. And so my new salary is going to be $10,400. I got a $400 raise because 4% of 10,000 is 400. Any questions on that? All right, so here's some other students' answers. All right, some other students like to put that it's 0.04, but again, that's not, 0.04 is the decimal equivalent, right? So this 4% is 0.04, and that shows up there. All right, let's move on. So this should look pretty normal to you, right? We have our question here that Jose is making $4,000 and gets a raise of 5% every month. This equation right here models that for us. So look at this equation right here. P of x equals 4,000 times 1.05 to the x power. Do you see how the A is right here, 4,000? The B in this case is 1.05. So take a moment and say, what is the A telling me and what is the B telling me? Well, if this is A and this is B, A is $4,000, right? That's his initial value. Notice, same language we've used before. That's the initial value. $4,000 is how much he starts with. That 1.05 means he is increasing his rate by 0.05, right? It's 0.05 more than his original salary. And so that is our growth rate or common ratio. We've been using these same things every single day. And so that's what A means. His initial value is $4,000. B means his growth rate is 1.05. Take a moment on slide 12. I really want you to walk through each of these big ideas. And so we're going to take a few of them and just kind of really dig into what does that mean. All right, so bear with me. I'm going to grab a little clip of this. So let's think about these big ideas. this should look very similar, right? It's the same idea, a times b to the x. So percentage big idea is right here. If we increase by 3%, then we'll have 103% of the original amount. So that's 100% plus 3%. And so our rate would be 1.03. If it's greater than 1, right? If it's greater than 1, we are growing. Okay? When it's greater than 1, we are growing. If it's greater than 1, we are growing. This next one, what if we decreased by 12%? Right? That would be 100% minus 12% for a total of 88%, or 0.88. Notice that's smaller than 1. So smaller or less than 1, we are decaying. And let's get my ugly face out of there. We are decaying. Smaller than 1, decaying. Greater than 1, growing. Write that down in your notes right now. All right, you need to know those two things. Take a moment, pause, and do that. All right, so greater than 1 is what? Yep, it's growing. Less than 1? Decaying. All right, let's clear this, and let's look at these last two special cases. So we've already done this before, right? But doubling the amount, that's times 2, right? 200%. So our rate is 2. Is that bigger than 1 or less than 1? Oh, it's bigger than 1, so we're growing. All right? And then if I'm having the amount, right, that's 50% of something. We've been saying that's 1/2, but we could also call it 0.5, like a lot of you like to do. Is that bigger than 1 or less than 1? Less than 1, so it is decaying. All right. You got it? Let's peek at our next slide here. So now you get to decide. Look at each of these rates here. We have 1.12, 0.9 or 0.90, 1.025. All right? And so you need to decide, are each of these rates bigger than 1 or are they less than 1? Are they bigger than 1 or are they less than 1? And then you're going to type either a capital G or a capital D for growth or decay. So go ahead and fill all these out, and then we'll talk about what this box means in a second. So go. Do your answers match? Right? Do you see that 1.12 is bigger than 1, so it's growing? 0.9, smaller. 1.025, just barely bigger. And 0.79, smaller. 0.875, smaller. So those are decaying. Now let's grab our calculator again. Go ahead, grab your calculator. And let's talk about what this percent rate is. So the idea is we're going from 1 to some bigger percentage. So how much is it growing here? Well, all you need to do, right, is take this and 1.12, subtract 1, and you can see that decimal growth, right? 0.12 means what is our percentage of growth? 12%. Okay? And if you click try it, you should get this nice green check. Decaying. Now, if it's decaying, how much smaller than 1 is that? If you can't see it, go ahead, go back to your calculator, and now go 1 minus 0.90, and you can see 0.1 is 10%. Right? So if it's smaller than 1, 10% to get back to 1. If it's bigger than 1, 12% to get back to 1. So go ahead and try these out and see how you do. So take a moment. Did you get all those green check marks? If not, what are you missing? Notice 0.25 is the decimal 0.025. 21, or 21%, it is 0.21 away from 1. And 12.5, it's 0.125 away from 1. And so you need to get back to 1 to show what percentage it's either growing or decaying. Watch this again if you need to. The next video is coming out shortly to finish up this lesson.